righty. We are just starting our June edition of the DSUA webinar. See everyone's starting to file in here. So as we're filing in, I'll start to go over some housekeeping items and just general introductions. So everyone get settled, get comfortable. Again, thank you for joining, everybody. My name is Mitch Lund. I am a technical advisor to DSUA and spend a lot of time working with Travis and Jerry Hunt on organizing and broadcasting these webinars. So we have a great slate of guests on hand today with IGTS and Evonik to do some new presentations for everybody joining and for us. But certainly before we get to the meat and potatoes, we are going to go over some of the basics for those that this is their first webinar joining, attending, watching. The Dry Scrubber Users Association is a nonprofit organization that's been around since 2008. And our objective is to promote collaboration and innovation of dry scrubbing technologies. That's CDS, that's SDA, that's DSI. That's our primary mission. In fact, if you look at our motto, it's pretty simple: exchanging valuable knowledge. So I think that's what it is, exchanging valuable knowledge, yeah, or information, one of the two. That's our primary goal objective. Our other goal is to provide opportunities for networking for professionals in the industry. Certainly that's a little tougher over the last year. For those of you that know, we canceled our in-person event this year. Obviously that's looking optimistic for next year, but we had to cancel it due to the uncertainty with the global pandemic. But we're going to continue to pursue these monthly webinars to stay engaged and to keep providing content for our viewers. I will say that while we canceled that conference in 2021, we are partnering with Enviro Summit and Travis Bowman's team over at Enviro Summit to participate in their conference in Charlotte, North Carolina this year. That is going to be in September. DSUA will have a dedicated breakout session at that conference. If anyone is interested in presenting, you can submit abstracts now. You can send that to either myself or Travis Reynolds, our moderator today and our VP of the DSUA, or Jerry Hunt, who's our president of DSUA, who is not on this webinar, but for those of you that have attended, he's a familiar face. So looking at getting content for that. If you're interested in learning more about the Enviro Summit, we actually have a section on our website homepage. If you scroll down, there's a section with FAQs and all that stuff to learn more about it. Our website, for those of you that don't know, is dryscrubberusers.org, dryscrubberusers with an S at the end, .org. And then certainly, here's the good stuff. If you email us wanting to register, you can receive a discount code to receive 25% off registration. So hopefully that removes some barriers for those of you that budget constraints, whatever. The other thing I want to note is that these webinars are recorded. They're uploaded to YouTube for future viewing, sharing, etc. We usually try to have those recordings available within a week or less. So keep an eye out for your email. You can follow us on our LinkedIn page or simply check in on our website. There's a virtual conference tab at the top as part of our homepage. So before we get into the first presentation today, which is IGS, we are going to acknowledge our sponsors because they keep the show running, right? So I'm going to share my screen. We're going to go over our first batch of sponsor commercials, and then we'll get into the presentations. 1 minute. Let's share that screen. All righty. Okay. So first sponsor we want to acknowledge is a new one, Carter Fujikin. They are a manufacturer of ceramic control valves, been around for over 45 years, and they service across the globe. And primarily function within the United States, 35 years within the United States. Their ceramic control valves are designed for erosive and corrosive media environments such as lime slurry, recycled ash, gypsum, the stuff we find in power plants all the time, right? Their ceramic control valves are also utilized in a number of industrial applications, including but not limited to pulp and paper, chemical, and refining. So thank you to Carter Fujikin for sponsoring. Next is National Filter Media, NFM. They take pride in being one of the world's oldest and largest providers of air pollution control and liquid filtration products. They're successful in adhering to the same business principles they've been practicing since being founded in 1906, which they believe in building partnerships with end users and earning business on a daily basis. Don't get complacent. So, and again, while filtration technology has changed since 1906, their commitment and their principles have not. So thank you to NFM for being a continued sponsor of DSUA. Next up is Lhoist. Lhoist North America, they're a subsidiary of the Lhoist Group based out of Europe. They're a global supplier of limestone, quicklime, and hydrated lime and silicate minerals. Some of their main products you'll see on the screen here includes enhanced hydrated lime, which is engineered to optimize dry scrubbing solutions used to control acid gas emissions at power plants and many other industrial facilities like pulp and paper, like chemical, etc. Want to give a special shout out. So I'd like you to check out the November 2020 DSUA webinar that was hosted with Ian Saratovsky of Lhoist North America. In that, you can hear about how using enhanced hydrated lime products in conjunction with DSI can be used as a standalone or an integrated solution for acid gas emissions control. Also would point you to the 2021 Platinum member podcast to learn more about Lhoist and their products and capabilities. So thank you to Lhoist North America for being a sponsor for DSUA. Next up is Reaction Analytics Solutions Corporation, RAS. They specialize in engineering solutions utilizing CFD modeling. Their founder, which is Dr. Guisu Liu, has spent 2+ decades in fuel combustion and emission control industry, and he's developed over 100 CFD models throughout his career. He's very experienced. Whether front-end combustion or back-end flue gas treatment, RAS can support from modeling the process chemistry to optimizing interface of chemicals and exhaust gases. They recently used DSI, ACI applications to optimize sorbent utilization with CFD models. So dry scrubbing is a top of mind service for RAS. Also want to point you to the May 2021 DSUA webinar for the presentation from Guisu in conjunction with Noltec about how use of CFD modeling can help optimize dry scrubbing solutions. So thank you to Guisu and RAS for being a valued sponsor of DSUA. Next up is Primex Process Specialists. They provide comprehensive help for SDA, CDS, and DSI users to optimize scrubbing performances and operations. They have over 20 years of customer success demonstrated through a unique combination of knowledge, technology, and patience. Those familiar with DSUA from the past and watched webinars will be aware of their expertise, as Stewart Nichols has previously presented in November 2020 on this webinar, and in February 2021. So they're a valued partner with us, and I'm certainly a valued sponsor of DSUA. So thank you to Primex. Last but not least, we have GE. It's gonna be a nice segue to my moderator, but GE Power Portfolio offers steam power technology for fossil and nuclear applications, including boilers, generators, steam turbines, AQCS, digital solutions, and more to help product power efficiently and provide performance for the life of the power plant. That's a mouthful. They've installed 30% of the global steam turbine capacity and 50% of steam turbines for nuclear power plants, as well as 30% of world's boilers and 1,500 steam turbine modular retrofits. So certainly experienced. They're able to help customers from best in-class upgrades and retrofits to core operations and maintenance across more than 90 OEM brands. They have over 6,000 field service employees delivering solutions to secure productive future for coal and nuclear power plants all over the world. Travis Reynolds, who is going to be our moderator for today's episode, is currently our DSUA Vice President working alongside Jerry Hunt, as I mentioned. He has been instrumental in our webinar efforts by taking the lead with establishing the Zoom platform use with these webinars. So a special thanks to Travis. Want to also point you to the September 2020 DSUA webinar to hear TBA talk about using GE's NID technology for further benefit. So that's first half of our call outs to our sponsors today. Without further ado, I will introduce today's moderator, Travis Reynolds. Travis has been working with GE the past 15 years. He's a valued partner of us. We couldn't do this without his efforts. So Travis, without further ado, take it away and introduce today's first speaker.
Thanks, Mitch. I appreciate that. All right, well, we'll jump on in here and get the first presentation rolling. So presentation number 1 today has to do with eliminating corrosion-related failures in spray dryer absorbers, and this will be presented by Andrew Kline and Jan Albert Schutte from IGS. Andrew Kline is currently responsible for the business development activities for the environmental division of IGS. He graduated from the Virginia Commonwealth University with a degree in mechanical engineering, and he has been heavily involved with solving efficiency and reliability issues in both dry scrubbers and SCR applications since 2015. Jan Albert is IGS's global product manager for thermal spray. He's a mechanical engineer and joined IGS in 2010, and he obtained 10 years of international operational and technical experience in solving erosion and corrosion problems in mission-critical equipment. With that, I'll turn it over to you fellas.
Awesome. Hey, everybody. Thanks for joining today as we have to do everything remote now. Looking forward to seeing everybody in person when that comes back to normal and changes. But as Travis mentioned, IGS is a global provider of in-situ applications for primarily HVTS solutions that eliminate corrosion and erosion throughout various industries. And today we're going to talk about how we have applied that in the dry scrubber industry, and some of the new technologies that have been developed and continuous development and improving that. So just a quick background. I know a lot of people have seen this slide, but IGS is a U.S. company based out of the U.S. With 2 offices, one in Richmond and one in Houston. And we have satellite offices and execution centers all over the world, primarily oil and gas and power, about 50-50 split there, but then also servicing pulp and paper and some other smaller industries as well. We like to kick off all of our presentations with a safety moment. Obviously, we're a field service entity, so field safety is very important for everybody. And I had an interesting experience over the weekend that nothing bad happened, but it caused me to turn around and go, man, that was a little dumb. I was out on the Chesapeake Bay, and we were going back to a marina by boat, and we had an option to either go back to the marina, which is about a 15-minute ride, or go back to the dock, which was an hour ride the other direction. The rest of the group went to the marina, and I let everyone know at the marina that I was going back to the dock, but I didn't tell anybody that was back at the dock that I was going back to the dock. And realizing I was leaving right around dusk, and part of it was a night ride, and on the bay, if something happened and you drifted out, didn't have cell service, no one was really expecting me. So it caused me to take a step back and think, one, how dumb that was, but also how that relates to travel. I mean, most of us travel for work. Make sure people know where you're supposed to be. If you get stranded out there and no cell service and an hour's walk in either direction, that can make for a really bad time if someone's not aware. So, but today, jumping into the meat of the presentation, kind of doing a broad overview of what causes the corrosion, why we're seeing more corrosion in recent years, and an overview of a case study from about 10 years ago that's been in service the full time. Then lessons learned from some other situations and how we were able to make improvements on the already reliable technologies. And then kind of what is it? How's it work? How's it relate to the changes we've made? And then lastly, what are the advantages of the changes made to the technology in the SDA applications? So we all know the basics on dry scrubbers. They're designed to be dry. They're not supposed to have any aqueous solution hitting the wall, any moisture, anything like that. So most of the OEMs made them out of carbon steel because it's cheaper and it should work. But as we all know, this day and age, we have cycled loading, we've got low loading conditions, we've got economic reserves, different injections for different reasons, some emissions control, some efficiencies. All of these things can change the chemistries and the environment in the SDA, and that can lead to a lot of these corrosion issues. And what we've seen is there's some units that always had corrosion issues that were well known and documented, and they knew they had to deal with them. But on the flip side, we've seen more and more units that have been periodically checking to make sure that they have wall thickness and aren't experiencing loss. And then all of a sudden, this last check, they had a dramatic loss in wall thickness. And I think that's really in part to the cycled and low loading conditions. It allows us to get closer to the acid dew point temperatures, and also different flow parameters allow flows not to be uniform. Wetting can occur in one area. Overspray might be happening because of the flow discrepancies and things like that. And what does that cause? I mean, obviously, we've all heard the stories at this point of some of the catastrophic failures and collapses. Huge safety concern. Luckily, no one was hurt when the one pictured here happened. But as you can see, significant downtime, significant cost to repair, and just all around a preventable situation. But also on the lesser ends, as we're aware that can happen, just wall leakage. When you start to get pinholes and larger holes in the wall, you have air-in leakage, which can cause a host of issues for the mixing of the gases and the efficiencies and the pressure drops through the system. But then also contamination out, which can be a safety issue. And then the cost obviously associated with fixing all that. Just another view of that collapse. You can see the penthouse here dropped about 8 feet. Luckily, no one was up there, and luckily it dropped straight down and what we call beer canned, where it just crushed. But if it would have gone sideways, you can see the control room is right there. And that could have been way worse than it was. So luckily it was not, but definitely an eye-opening experience for everybody. So another situation where it was a similar corrosion issue in the spray affected zone of the Antelope Valley SDA units. They were experiencing wall thickness. They knew they were having the failures, and they wanted to freeze the condition before it got worse. So they turned to IGS in 2011. Well, I guess turned to us before that, and worked with us to take samples of the failed material, work with our lab, analyze what was going on, what was causing the corrosion, and then develop a HVTS solution specific for that application. And it was installed in 5 of their chambers in 2011, and then 5 of the chambers of the other unit in 2013. And you can see the application photos and then the photo of the new application there. Now, it was inspected in May 2014, which is a relatively short time period after the installation. But when it was inspected and the slagging was removed from the wall, it was clear that there was no discoloration or anything like that to indicate corrosion. And we were actually able at that time to use an alcometer to do some spot checks of thickness. and there was no thickness loss off the nominal thickness. Something that's important to note is with a corrosion application, which is much different than a erosion application in this sense, if something's going to fail, it's going to fail relatively quickly for the most part. There's some cases that can saturate materials and things like that over time that will cause longer failures. But in the expected lifetime of the material, if you're going to have a failure, you're going to see it very soon. So that was a good indicator from the beginning. Now we were able to get back in and inspect in October 2020. And during that inspection, we only had access from the access door. So we weren't actually able to get up to the spray affected zone where the coating was. But in this photo here, you can see that under the slag or any of the ash accumulation, that there is no discoloration in that spray affected zone. And you can see almost clearly the lines of the coating on the top and the bottom. However, on the top and bottom around that zone where there is no coating, you can see the carbon steel has started to turn and is showing signs of corrosion. Now we talked to the plant and said, hey, make sure to pay attention to those areas because, and this is what we've told everybody now, is once you've coated the 90% of your problem, which is typically your spray affected zone or the crease in the cone, well, then people just kind of often fix the problem and move on to the next thing. But 10 years later, you can come back and you've fixed your bulk of the area, but that area above and bottom still needs attention because if you don't want to neglect that and then over time have a failure in that region. But a detailed case study with some more photos and more detailed information of this is available. Feel free to email me. My email is at the end of this presentation, then I'd be happy to send it to you. But, you know, with that being said, any coating company out there that has done multiple installations is going to have some examples where failure occurred. And that's what defines the difference between the companies out there is, one, how you react to it, and then two, can we improve it? How do we make it more robust? So we had a installation that we're highlighting a little bit here that had some compromised coating areas in the unit that were significant. And an HVTS solution had been designed specifically for that application. But what we found during analysis of what happened was that the parameters that the coating was designed to operate in were vastly different than the situation that was actually occurring. Two major factors played into that. One, this unit was utilizing the SDA as their wastewater treatment. So instead of processing the wastewater, they were just dumping the water and having it evaporate off, which threw all of the chemical balances completely out of whack from what was expected to be in that unit. And with any metallic coatings, you have to make sure that the materials in there are inert to the other materials you're working with, which is why in a marine application where you have corrosion from salts is very different than a reducing atmosphere situation or something where you're going to have sulfides. You got to make sure it's matched appropriately. And there are coatings that cover both, but you optimize for the specific application. Another thing that happened here was on multiple occasions, the atomizers had been operating and spraying slurry with no flue gas in the unit. And when you have a coating that was designed to be in a dry situation where you might have moisture, but you're not exposing it to a fully aqueous solution, when you actually do wet the wall to that point where you're not drying it with flue gas, it changes the situation drastically as well. So after that, we took a step back and go, how can we design a system where we're utilizing all the strengths of the thermal spray that we'll talk about in a minute? HVTS is synonymous with thermal spray. How do we use all those strengths, but broaden its protection while remaining cost effective? And that's really the key. I mean, it's sort of that triangle. You know, you've got your cost, your protection limits, and you got to balance them, because obviously if you protect against everything and you put it in STA, it's going to be overkill, and you're going to price yourself out. So that caused us to develop this hybrid coating that we're going to talk about. And it's called MRP, metallic reinforced polymer. And it really utilizes the best of both worlds and reduces the overall cost of the coatings. And going to turn it over to Jan here, because the first step of understanding MRP, because it's part of that application, is understanding what thermal spray is and then how MRP interacts with it.
Hey everyone, thank you, Andrew. So yeah, I'm just going to start off with a quick overview of thermal spray. It's the first ingredient or building block to our MRP. So understanding of that is necessary. So thermal spray is, it's really the process where molten particles are propelled by some carrier gas to a substrate to form some sort of protective lining. It's also known as metal spray, and can also be seen as like a alloy upgrade. If you wish your equipment was made out of a HEST alloy or stainless steel or titanium, that's actually possible to do that with thermal spray. It's grouped into electrical heat sources and chemical heat sources. And then you've got various technologies under each of those groups. So the picture on the bottom left just shows you the process where you've got spray material going into the spray gun, either in powder form or wire form. You've got some form of energy, whether it's electricity or combustion. And then you've got the particulates being projected onto the substrate. And one thing just to keep in mind, it's not like a solid molten metal layer. It's metal spray or thermal spray is built out of individual particulates. And that effectively forms a barrier. So another great advantage of metal spray or thermal spray is that it's a mechanical and a chemical bond. So unlike weld overlay, which is a metallurgical bond. So there's no heat affected zone. So you get the benefits of weld overlay without the disadvantages. A last thing on this slide, things to watch out for is when those molten particles leave the gun, and they fly through the air, they fly through oxygen. So you really need to watch out that those particles don't oxidize. Otherwise, you're going to have a coating that's full of oxides. And then lastly, you need to take care of the size of your particles. And there's various ways of doing that, which includes taking care of your process conditions and getting the airflow up to supersonic gas speed. So the next slide. Just shows, this is the thermal spray process IGTS typically does. The thermal spray, our company has started in the paper and pulp industry probably 30 years ago, maybe even slightly more than that. And since then, a lot of time has been spent on developing both the materials and the processes. Up to a point where thermal sprays now were recognized solutions to most industries, most big names, and most major oil and gas conglomerates, such as the Chevrons and the Exxons and so forth. So it's really it's a well-recognized, well-proven solution with various case studies out there. Next slide. So
Jan Albert,
hey.
I'm gonna go ahead and well, we haven't got any questions yet, but I'm gonna let the audience know that they can submit questions to you that we can either address at real time or at the end by going to the bottom, and there's a Q&A button. And if they hit that, they can just type their questions in. I expect there'll be several questions for you on this. Sorry, go ahead.
Okay, good. Yeah, you're welcome to interrupt me with questions, Mitch or Travis. So yeah, so this slide is just thermal spray. It has improved over the years. It's been around for quite a while. It's really been around since the 1930s. And since then, there's been certain approaches which is winning approaches and some failing approaches. And some things to watch out for in thermal spray is if you look at these pictures, which is really cross sections. So if you spray on a plate and you cross section it and you look under it under a microscope or SEM, this is sort of how the coatings look. And things to look out for is low velocity processes, which results in big droplets and irregular particle sizes. And next one is oxides, which I mentioned earlier, which really causes a pathway for your corrosive media to work its way through the coating and to the substrate. The next two is stress fracture or microfracturing. Not good for if you're trying to get an impermeable coating. So you have to watch out for all of these, and there's really what you're looking for is the one on completely the micrograph on the right-hand side, which is a high velocity coating, low oxides, low stress. It's not permeable. It's very difficult for any corrosive media to work its way through. And to achieve this is really, there's proven precautions out there to take when selecting material or equipment to apply thermal spray to achieve these results. So that's a quick overview of thermal spray. So what is MRP? So MRP is fundamentally a metallic system coupled with a top coat. So this means it really gives you the ability to broaden your protection range. And it's also not that sensitive to mechanical damage. So that's a big deal when you've got scaffolding going in and scaffolding going out of equipment. If you whack metal spray with a piece of scaffolding, it's still going to be fine. So since it's a metallic system, the metallurgy can be selected very specific for the process environment. And then the metallic layer can also be optimized to give you the best protection, but also optimized to give you economic and cost-effective protection. So when this metallic layer is combined or coupled with a polymeric top coat, then you really get a protective layer that's highly resistant to chemical attack, mechanical damage, or even thermal mismatch. So, and furthermore, the system, because it's metallic base, is not sensitive to all those environmental controls necessary for typical organic applications. So I've got there's a picture at the bottom here that just shows the light gray is your substrate, which, for instance, would be carbon steel. And then you've got a blast profile, which really facilitates for a very strong adhesion. For the HVTS cladding. And then the cladding itself creates a metallic layer for the non-metallic polymer. And it provides an excellent sort of reinforcement media for that polymer to grab onto. And then that polymer in itself it gives you a range of properties, chemical properties, to give you further protection. So really the best of both worlds from both technologies. So MRP is designed to be effective against all these wastage mechanisms in the pictures: pitting corrosion, acid attack, dew point corrosion, erosion, and also fouling. So it reduces the critical path time. It's practically no curing. So once the metal spray has been applied and the top coat has been applied, then within 12 hours of application, you have the equipment back. So it gives you some resistance to steam out and also mechanical damage, as mentioned before. If there is a spot that's been compromised or damaged, it's repairable. So no need to strip everything. You can repair just that spot. And then the ultimate goal here is to skip shutdown cycles. So it is considered a long-term solution, not a temporary solution. And it's provides you that protection at the fraction of the cost. So looking at the last slide,
John,
yeah.
we have a question. We have a question just came in for you. Can you discuss what types of QC measurements are used to be sure the HVTS and MRP have been applied properly?
Yeah, that's that question comes with great timing. That's about the slide that I'm talking about now. So yeah, good question. So the installation process is step one is blasting. We're looking for a white metal finish, and we typically use garnet to achieve that finish. One thing to watch out for is just to assess your surface once the blasting is done. In terms of pitting or sharp edges. If any of these do exist, they need to be taken care of, like sharp edges needs to be removed or pitting needs to be opened before HVTS gets applied. So that's the first step. Blasting is white metal finish. And then after blasting is followed by a QC function to make sure there's no holidays in the blasting and the white metal finish is achieved. And then step B is where the HVTS gets applied. And directly after the HVTS application is followed by another QC using alcometers, such in that center picture there, to verify that you've got a thickness of 8 to 12 moles. So depending on the application, there's a specific range which we need to stay within. And once the step one, A, B, and C is done, so once you've blasted, applied the metal component, and did your QC, we also do a coating thickness map of the entire scope area. And once that's done and that's satisfactory, we apply that top coat that we mentioned earlier. So that is the basic steps. I'm not going to go into too much more detail. There's no harmful fumes, no explosive vapors. As mentioned again, no need for dehumidification equipment, temperature control, and practically no cure time. So. Yeah, so Andrew, back to you.
Sure, thanks, Jan. So, you know, this last, or as we're getting to the end, but this is kind of the comparison slide. What are the pros and cons? We highlighted some solutions here. Now, there's also other solutions on the high end and the low end, such as wallpapering or alloy upgrade. I'm not really going to focus on that. We're really focusing on the primary coatings that are used in the SDA market. And I'm not going to start off by saying all coatings are good and some don't work and things like that. For each category and applied to the proper application, all types of these coatings can be long-term solutions in an SDA environment. When you come down to some of the organic coatings, the most important thing to focus on is, one, do I have the right material? And have I done the right surface prep? And they can be successful for that application. So this comparison, you know, once I've realized, okay, I can be successful in the right application, what are the things I'm looking for to help me make a decision on which is the best for me and my application? So kind of broke out this chart and bear with me. I'm trying to move the little bar that we see everyone's faces with because it was in the way, in the middle of that screen. But really want to highlight a few things here. You know, the HVTS is very robust, but to achieve a broad spectrum of protection, the cost goes drastically up. And that's really the biggest downside to the HVTS. We work to optimize that and control the cost to an extent, but lose a little bit of that flexibility for those upset conditions. And the MRP really landed in the sweet spot of being a lower to medium cost application. However, increasing that broad range of protection for a wide application. So there's really two ways to break this down. One is focusing more on installation cost and the overall cost of ownership, and then some of the technical advantages of the installed product. And the things I'd like to highlight the most, MRP also bridged the sweet spot of not having significant concerns other than your standard dust, like sandblasting creates in the application process. HVTS, with many of the chrome alloys used, have high levels of hex chrome, which is a serious concern. We're very good at mitigating it because that's the majority of what we do. That being said, it still can impact your SIMOPS, upstream, downstream, cost of mitigation and things like that. And then on the organic side, oftentimes you're going to see toxic and explosive vapors. And there have been documented cases where people have been hospitalized in SDA applications from an installation with those toxic vapors. So by eliminating those two, that's a significant safety concern and cost mitigation that's taken out with MRP. The other is really the cost of controlling temperature and humidity. So in a local application, that's relatively easy, but in the larger vessels, that can be very expensive during an installation. With the MRP and the HVTS solutions, as long as you're not running water down the wall, you're not very concerned about the humidity in the atmosphere. So oftentimes, or pretty much all the time, you can eliminate the costs of requiring that temperature and humidity control, which can be very significant on some of these large scale options. So when you take all of that, and then your cure time, MRP, by the time you're done applying that second coat and you're starting to pull scaffolding, it's cured. So there's really no impact to scheduling, where organics can be 12 or more hours to cure. So taking those things into consideration, when you look at the overall cost, not just the material cost, MRP and organics are going to be in a very similar playing field, where the HVTS is going to stay on the higher side of that. Looking in at the technical advantages, though, and decision processes, the one that stands out the most is really the ability of MRP to handle higher temperatures than the organics that are out there. Typically, organics are really limited at 300 to 375. They can go to a slightly higher excursion temperature for a period of time, but you do risk the charring during that. And with thermal cycling, that because your substrate and your coating grow at different rates, over time, and with those thermal cycles, it can cause some delamination or cracking or porosity to occur in that coating, which then leads to a coating failure as the corrosive media gets behind it. By using the HVTS layer, has a similar thermal expansion rate to the carbon steel, and the top coat is impregnated into that coating. So now you're not dealing with that same thermal mismatch anymore, as Jan mentioned. So it's much more robust to thermal cycling and things like that. Also talking about the overall durability. If I'm using aggressive cleaning methods, if I'm taking scaffolding in there, in and out, other things that can cause that, the MRP, because that top coat is impregnated into that HVTS layer, you have a higher resistance to erosion and physical damage. than you do with some of the other coatings. That being said, HVTS is going to be the best option if you have high erosion. The MRP is still a compromise in there. As we talked about, the repairability. Some of the organics are repairable in local areas. Some of them aren't. But both the MRP and the HVTS are easily repairable on a small area. So, you know, and the other thing to mention is another thing that causes failures over time with a lot of the organics is this idea of, or the concept of saturation over time. Think of the coating as a very non-porous sponge, but still has some porosity. And that corrosive media over time impregnates its way into some of the organic options. And once it reaches the layer that it's able to get to that substrate and that coating gets saturated, the system delaminates and comes off the wall. The interface between the HVTS zone and the top coat polymer is one, it's interlocked. So it's very close and dense, but you lose that ability of that corrosive media to impregnate its way through. So even as it impregnates into the polymeric layer, that interface zone stops it because that base substrate is corrosion. It's non-reactive. So it's not even corrosion resistant. It's that coating doesn't corrode. So it essentially stops it and won't let it continue to impregnate into the wall itself. So that's some of the ways you're able to get extended life there, where the some of the organic systems say, well, to give me a longer life because of that, I'm just going to put on more thickness. Well, that adds internal stresses to that coating. So you might have prevented it from becoming a prevented it from the saturation phenomenon. But now when I have more internal stress, I've raised more issues with thermal cycling and things like that, where with the interface on the MRP, you're able to get that same protection without adding thickness. So you don't negatively impact any of the thermal cycling or life cycle things from that side. And that's the bulk of that presentation there. And here's our contact information. Like I said, if anyone's interested in that case study or any other general questions after this or something comes up, feel free to reach out to either of us. And with that, we'll open it up for questions.
Hey, Andrew. Thank you, Andrew. And Jan Albert, we got another question that came in from the audience here. Can this technology be applied to water wall corrosion in a boiler?
So the MRP solution is, there is different temperature ranges where you can get higher than 800 degrees with some of that MRP technology. The real proven technology there, though, is the HVTS. That's the bread and butter of what HVTS was designed for, was water wall corrosion on boiler tubes. Also erosion. I mean, there's different applications. So for a CFB, for example, it's going to be a different material than you put into a low NOx burner situation, where you would have that reducing atmosphere and fireside corrosion. But for that, and Jan's actually the expert on that, much more than I am, but that is specifically, there's HVTS coating specifically designed for that application that have been proven time and time again over 10, 15 years. So that I wouldn't recommend looking into the MRP for that. It's not really designed to be that high temperature boiler application, and it's more going to be in your low to mid temperature range applications where corrosion is the primary driver. So an SDA fits the bill nicely there. Bag houses are another area, storage tanks, a lot of things on the oil and gas side that Jan can talk about, where they're higher temperature, but there's like aqueous solution systems and things like that.
Okay. All right. Thank you. Well, I think we're going to do one more question here, and then and we'll probably wrap that your presentation portion. Early on, one of the earlier slides you showed, you showed the top line, bottom line, and kind of the range of where the spray cloud was going to hit the wall. Is your recommendation that that's the main area that's treated, is just where your expected spray cloud impingement is? Or, I mean, are some customers looking at, obviously they'd probably go beyond that for safety, but are customers also looking at doing the whole sidewall, or what's your experience there?
Sure, that's a great question. So obviously it's a function of cost. And if we are looking to get the maximum bang for the buck, they've been looking at just the spray affected zone. One of the nice things is, though, because obviously corrosion can happen outside of it, and especially if you have excessive buildup, a lot of times that cone section, acid dew point on the cone, if you're getting colder areas down there, it condenses, so you get moisture there. It's really a case-by-case basis. Once you've seen, okay, where are my problems, you can optimize. But some customers do opt for complete protection, and once again, a function of cost. But the nice thing is with the MRP, it brings the cost point down. So maybe where the HVTS, because of the cost, I only have enough in my budget to do the spray affected zone, which is 80% of my problem. Now I can actually look at the protection of the full vessel. So case by case, there's customers that have done both, but obviously to be on the safer side of a more robust solution would be doing the full vessel.
Okay. And we did get one more question here, and I think this will be probably a rather simple answer from you, so I'll just go ahead and give you this one. Has IGS applied HVTS or MRP to fan housings or blades for corrosion control?
Jan, you might know more than me there, but I know the short answer is yes.
Yeah, yes, and then we've got some case studies to share on that, especially ID fans from corrosion and erosion point of view. So yes, we got some case studies on that, which I can share.
Okay, thank you. Yeah, if the person who asked that question, if you would like more information, you can just shoot us an email and we'll get you in touch, or you can reach out to Andrew and Jan Albert yourself and see what they can get to you. Okay, thanks guys. Mitch?
Thank you.
No, that's great. Great stuff, Andrew. Thank you, Jan Albert. That was awesome. I'm just going to go into acknowledging some more of our sponsors before we get into our next presentation with Evonik. So I will share my screen real quick. I think. All right. So IGS, you guys might have heard of them. They obviously just wrapped up their last presentation, but IGS is another sponsor of DSUA, international provider of surface protection and material handling solutions headquartered in Virginia. They have 30 years, more than 30 years of experience helping customers solve metal wastage, ash accumulation, and general liability problems in mission critical equipment. Obviously also doing some innovative surface treatment techniques that they just presented on. They're an industry leader in the development and application of solutions for corrosion and erosion problems in challenging operating environments. So thank you to Andrew, Jan Albert, and the IGS team for sponsoring DSUA. Next up is Lechler. Lechler has over 140 years of experience designing and manufacturing spray solutions for air quality control systems. They have a wide range of nozzle products, nozzle lances, valve stands, mist eliminators to provide solutions for gas cooling, purification, denitrification, and desulfurization applications. They advise customers with custom solutions to meet their needs to achieve compliance with stringent emission requirements. That's their core competency. Their experts understand spray technologies and share their expertise and solutions through partnerships with their end users. You might have seen the name Stewart Nichols be floated around on DSUA. He's with Lechler. He's a DSUA advisor with us, and he's been volunteering to support our current activities. So thank you to Stewart. Also want to point you to the March 2021 DSUA webinar for a presentation from Lechler, presented in conjunction with JEA, Jacksonville Electric Authority, about their SDA optimization efforts. So thank you very much to Lechler for supporting us as well. Next up is Gecko Robotics. Gecko Robotics uses revolutionary robotic technology for industrial infrastructure inspections based out of Pittsburgh. They have wall climbing robots and inspection teams that perform NDT inspections for global clientele. Their robotic technology enables execution of routine inspections with comprehensive data collection at high speeds that are collected safely in hazardous environments. In recent years, they've been very supportive of the DSUA through board positions. Shout out to Dave, who was our former VP of that, as well as really helping us facilitate the Zoom platform for the current webinar. So I want to also thank Sam Link and Amanda Venglish for their participation as well. Want to point you to a 2021 DSUA webinar episode presented by Michael Paul Jenkins of Gecko Robotics to learn more about their robotic technology. So thank you very much to Gecko for sponsoring DSUA. Reticam up next. Reticam provides extended range of equipment for flue gas treatment and air pollution control systems throughout many industries. They serve end users with technologies to meet stringent emission reductions in a cost-effective manner. They have a wealth of experience through 4 decades of operational experience. They are a reliable partner, whether it is a greenfield site, retrofit solution, or anything in between, to help achieve the desired air pollution control objectives that their customers are looking for. Salvatore Gallo, currently a DSUA advisor as well, who volunteers his time to support activities. So thank you to Salvatore and Reticam for sponsoring the DSUA. Last but not least, Mississippi Lime Company. They are a world-class producer of calcium products, including quicklime, hydrated lime, and calcium carbonate. For over 100 years, they have been producing products from one of the richest limestone reserves in the world, near the St. Louis area. They supply a range of products throughout North America and the world from over a dozen plants and terminals. They have high quality quicklime and hydrated lime, cost-effective products that are utilized by SDA, CDS, and DSI end users. Kurt Bean is a DSUA board member volunteering his time to support our activities, so thank you to Kurt. Also want to point you to the March 2021 episode as well to learn more about Mississippi Lime and their presentation about enhanced hydrated lime fundamentals. So thank you to Kurt, thank you to Mississippi Lime for sponsoring DSUA and all that we do. With that being said, we're going to transition to our second presentation of the day. Travis, take it away.
All right, thanks, Mitch. All right, presentation number 2 today has to do with use of LPPJ fabric filters in conjunction with spray dryer absorbers. This is going to be presented by Guenter Gasparin from Evonik and Nathan Schindler. Guenter is going to be the primary presenter here today, so a little bit of his background. In 2000, he graduated with process engineering from Graz University of Technology. Then he spent time doing R&D Department of Fair in Linz, Austria. And since then, he's been an application engineer at Evonik. So, Guenter, you can take it away.
Thank you for the introduction. Thank you, Travis, for handing over to me. Before I would like to start with my presentation, I would also like to express my thanks, not just to my colleague, Nathan Schindler, who is keeping fingers crossed today at the background, but also to Mr. Darren Griffin, working for ESB Moneypoint, our partner of this presentation, and providing us with all the valuable information that we have received from the plant and that I'm glad to present to you today. So, hopefully this works. Yes, now things are moving. My presentation today should focus also on the role of let's say, the fabric filter and the role of the fabric filter within this dryer dry sorption systems as well as conditioned dry sorption systems, because these apparatus are sometimes quite underestimated. Before we get into details of today's presentation, I would like to, let's say, introduce this little bit strange constellation between an end customer and a fiber producer first, by introducing both companies right now. So basically, Evonik Fibers is a fiber producer located in Austria, and we are producing polyamide products, and among these polyamide products is a high temperature fiber which has the brand name P84. This is used and has been used for industrial applications for a very long time right now. And it was born something like 30 years ago. And even in 2014, we have been celebrating our 30th years of history. And there is one major application that the fiber is in, and this is definitely the industrial filtration. So things and demands have changed in the last years, and we were introducing more and more grades into this industry. And in 2016, for example, just to give you some spotlights, we announced the introduction of a 1.3 fine fiber, which is able and suitable to deal with even lower emissions. In 2019, we've launched another product, which is the PD4HT fiber, with a fiber which has a little bit different chemistry than the standard PD4 fiber, and is even capable to deal with applications showing an even higher operating temperature than the standard one. Our partner, and I have the honor to take over this part of the presentation today as well, is the Electric Supply Board, ESB. The company is the producer of electric energy in Ireland, of course, with, let's say, headquarters in Dublin. They have an installed thermal capacity of, let's say, 3.8 gigawatts, mainly in Ireland, but also international in the UK. They have multiple units running on coal, gas, distillate, and also upcoming more and more renewables. So the range of the plants is also well shifted. Some baseload plants, and the plant we're talking today is a baseload plant, and two shifting hydro and pump storage. And it is worth to mention, of course, that the pressure on the whole energy sector is increasing steadily. So renewable energy is gaining more and more strength, and ESB is investing heavily in this, especially offshore wind plants. So now let's come to this application and plant that we would like to discuss today with regards to its history and its performance. So the Money Point is a coal-fired boiler plant located at the western shores of Ireland, alongside the river of Shannon, and close to the city of Kilrush. I hope I explained it, I pronounced this in the right way. So please, all Irish people, forgive me if I didn't do it in the right way. There are 3 units having a load of 300 megawatts electric each unit, pulverized coal-fired boilers, and for some coincidence, they were also built mid of the 80s, like the history of our fiber or PD4 fiber began. The coal that these units are burning is imported. So in the past, the plant has used South African, Colombian coal from USA, Indonesia, and Australia. The current supply is Russian coal only. So this is the status quo over the last few years. Having a history back in the 1980s, this plant had to make a serious number of retrofits in the past years, including upgrades or building SCR units and also upgrading the flue gas treatment system. So there was a big project ongoing in 2008 and 9, where really there was a strong focus on building an SCR unit and an FGD unit. So the turnkey project was done by a company called Lentius, and we will see in a few minutes a very detailed view on their apparatus. Coming to this flow sheet of the flue gas treatment system. So we see here on the right hand side the boiler unit. The boiler is still the coal-fired boiler, so we don't see in this flow sheet any heat generation, turbines, and so on. We are just focusing on the main apparatus of the flue gas treatment system. So we have, first of all, downstream the boiler, the SCR unit, selective catalytic reactor, typical design, so with the typical, let's say, dimensions that are used in these high dust areas of coal-fired boilers. And this is more or less the first unit that was adopted in this transition period 2008-2009. Then we have downstream this SCR, the existing or the old, let's say, ESP, which was of course there before the upgrade of the FGD system was done, and also the old ID fan. So it is still in operation, reducing the amount of fly ash being brought to the scrubbing unit and then the fabric filter later on. So next is this combination of scrubbing unit and fabric filter, where the focus of today's presentation will be. So it is shown in this slide. So a little bit more in detail, the FGD system. So we have what is called a conditioned dry sorption system. That means you're not just adding the absorbent from a silo, which is in this case hydrated lime, but you're also adding water. And this is a vertical tower. So at the bottom end of this tower, the flue gas, the hydrated lime recirculates, come together, are being mixed in a very highly turbulent zone. And then there is a certain residence time in this apparatus. And after that, flue gas, the clean flue gas, as well as the dust is entering the fabric filter. The fabric filter, of course, needs to eliminate all dust components, letting the gas passing through the filter elements. But it is important to mention that this system is a recirculation system. So that means that only part of this, the product is discharged, the main part is recirculated. This is also for economic reasons. And there is a further recirculation of the flue gas. So in order to keep, let's say, certain flow conditions in this FGD system, also the flue gas can be recycled to a certain degree. A little bit more on the fabric filter house. This is what the industry knows as the Lurgi design. So you have several bundles of oval-shaped filter bags. They are collected in several chambers. So 2 bundles are in one chamber. And in total, you have the installed number of bags is 11,760 with a length of 8 meters. So the total filter fabric installed has an area of 37,630 square meters. The material that is used is partly constructed of our PD4 material, as well as the main portion of this material is polyphenylene sulfate with shortcut of PPS. And fabric weights and are also typical for industrial filter units. So what is important is that this is a low pressure cleaning system. That means that the cleaning is not just done by such a very harsh pulse jet that is entering each individual filter bag, but it is really rather evenly distributed, and this is more like a flushing. So also here we have again some pictures of the overall plant. A few figures of the operating time and operating conditions. So the plant, the filter bags that are currently in have seen, let's say, a significant workload so far. So unit 1 and unit 3 are close. Unit 1 is even close to 40,000 hours. Unit 3 is close to 38,000 hours. Unit 2 has not seen that many operating hours, but they're informed me that both units 1 and 3 are used to provide the base load, and the unit 2 is running not that frequent. So this is one reason why the operating time of this unit 2 is not as the same as the one of unit 1 and 3. The operating conditions are pretty much in the range of such coal-fired boiler units. So we are talking about flue gas temperatures in this scrubbing filter unit of 70 to 72 degrees C, which is transferred into empirical units around 160 Fahrenheit. So SO2, NOx, and dust are well in alignment in terms of the emission with the emission regulations of the European Union. And for economical reason, the plant is also running, let's say, with a certain distance to these allowed emissions. So that means we have SO2 emissions, which are allowed of 200 milligram. If the load is okay and they're really pushing the FGD systems, they can go down very low with the SO2. But if they're running base load, they normally try to run and operate at 150 milligrams. Similar with the NOx. Of course, if you're really overstressing the SCR unit and you allow a certain ammonia slip to the upper limit, then you can go down even further, but normally they run at 150 milligrams. And yeah, also with the dust, we have an emission limit of 20 milligrams. Normally they're in the range of 3 to 8. So this is something which is quite good and also quite low in whenever you consider that these the filter bags that are installed there are 11,000, and if you look for leakages or for some broken bags, then just one broken bag can cause some additional milligrams of emission. Yeah, the key parameter for a successful operation, and this was confirmed by Darren, is to watch all the parameters that are ongoing. And this is also the main topic of our today's presentation. So you have to take care of, let's say, all parameters coming from the plant. That means normally the people tend to check two things when you're talking about the fabric filter. The one is the delta P across the fabric filter. And the other thing is, of course, the dust emission. I mean, this is the most important thing for authorities. But if you really have a good experience with your bag filter systems, it also might be worth to look deeper into this pulse cleaning system, because before even a delta P is increasing due to some blockage of the bags or some other reasons, normally the cleaning frequency is increased. And this is something MoneyPoint is really taking care of. And of course, cleaning frequency can vary in a wide range. I mean, the more dust is coming in, the higher the cleaning frequency. So you need a certain experience in this regard. But nevertheless, this is one important thing that they are looking for. And of course, filter bags inspections. Here you see this typical view on the cell plate of such fabric filter with this Lurgi design, with this rotating manifold and the nozzles that are really flushing the air through these many filter bags aligned in circularly aligned and having an oval shape. Also, this must be done from the bottom in order to figure out if bags are touching each other, if the alignment is okay, and if there is any abrasion being detected before. So this is one part of it. So this can be done during outages or during operation. But of course, the one thing is also to extract the bags and to test them by external companies. These are, well, in this
Guenter?
case, yeah.
Sorry, we had a question come in. So the question was, the ESB operating temperatures are quite low and SOx levels are high. Can you advise what your corrosion experience is there?
So far, they didn't mention any, well, I didn't discuss this topic into detail with Mr. Darren Griffin, but I would like to hand over this question to him later on in order to figure out at the plant. I mean, it's all, and because this is, yeah, something I'm not able to answer right now.
Okay.
What measures they are taking, what precautions they are doing. I mean, I know that they, for example, pre-coat the filter bags. This is in order to prevent the damage on the bag material itself. Of course, this pre-coating layer also is coating the wall, but this is a temporary measure during shutdowns and startup procedures.
Okay.
So, okay, so this is a question that I would like to have handed over to the people from ESB Moneypoint.
Okay, thank you. We had another question came in, and back on slide 8, can you discuss the anti-fin treatment for the filter bags?
This is one of the, okay. This is one of the common treatments for oleophobic, hydrophobic performance of bag filters. So there are, let's say, several suppliers have their own codes, and this is the code that was used by the current supplier of the bag filters there. So, okay, but basically these are oleophobic and hydrophobic treatments. So that prevent any, let's say, absorption of water. So water repellence is increased with this treatment.
Okay, thank you.
Okay, so in back sampling and back testing is done, yeah, by many companies in this field. We do it not on a frequent basis because we are normally at the, let's say, at the beginning of this manufacturing chain, but we have a long-term experience with our materials, also with PPS materials, which we had in the program for more than 15 years. So we have a certain experience in terms of back testing, and sometimes we also do this for end customers. And this is one of these rare constellations with ISB Moneypoint, that it's not the bag manufacturer doing this bag analysis, but it was done directly by us, because we as Evonik Fibers have one of the, let's say, biggest databases in terms of when it comes down to the determination of the chemical aging of materials. So, and the key figures when you are testing bags are the following ones. You're looking for mechanical strength, for permeability, and let's say for other parameters such as dust penetration that might identify an upcoming, let's say, failure of the bags. But before we enter into this, I would like to spend some more minutes on the specific of fibers, and especially of the PD4 fibers. So the most crucial thing when it comes about filtration is that you need to, let's say, provide a certain high specific surface area. This can be done in two ways. Either you generate very fine fibers, or you have a regular shaped fibers. And this is the unique thing about the PD4. So it is the only really multi-lobe shaped fiber available on the market, and it's offering something like 60–70% more specific surface area compared to a standard round-shaped fibers of the same thickness. And if we go down even further this line as I mentioned before, that defining the fiber, the higher the surface is, we can end up at specific surface areas of almost 600 square meters per kilogram of fiber, which is calculated back on the standard fabric weight of a bag, something like 300 square meters per square meter filter bag that is provided just by the fibers. So this is the top end. And the reason why this is just helping the filtration is also shown in this SEM picture here. So here you see how the dust is, let's say, collected on different fiber shapes. The one fiber, let's say, that is more related at the bottom left side of this picture is a round-shaped fiber. You see some dust particles being adhering there, but the most particles are adhering in the lobes of this irregular shaped cross-section of the PAD4 fiber. So this is the physical background why the filtration performance of the PAD4 is significantly higher than the ones of other fibers. And this is also the main reason why a portion of this PAD4 fiber, which is normally, let's say, if it is selected just for temperature reason, not the first choice for coal-fired boiler plants, especially for these low temperature applications, was selected to be manufactured in the surface side of such a filter material. A filter material, as it is described here, is normally a three-layer construction. So you have the one layer that is showing towards the flue gas stream, and this is the one where PAD4 is part of the construction. So it is, as we call it, blended into this matrix. Then you have a woven construction in the center, which is related to provide mechanical strength, and also the clean gas side is manufactured from the base material, which is PPS, in order to provide mechanical strength as well as robustness. The filtration efficiency is therefore increased to a certain degree, and this normally leads to a picture that we see at the bottom right here. So we see that there is a certain dust layer on this fabric. This fabric is, the dust layer is near the surface. So it's not a straight line. Of course, it has some penetration into the construction, but it should be near the surface. And the reason why this is so important is the following. If we are talking about scrubbing systems, then it's not just their material. So the reaction, depending on the system, the reaction mustn't be entirely done in the reactor. There are systems where a significant portion of the reaction, of the desulfurization reaction, is taking place in the filter cake. And the less pressure drop, so the more you have this dust cake just formed on the surface, the lower is the residual pressure drop of this construction. Therefore, the additional pressure drop that is accumulated during the filtration cycle is helping to build a rich and porous cake, and is actually helping to make, let's say, the SO2 reaction and the SO2 reduction more efficient. So the story at Money Point is the following. This is the initial material was plain PPS. The PAD4 was used as an upgrade for the second set, and we are now approaching almost 40,000 hours of operating time. The bags that we extracting here are rather unspectacular, so we could not identify any mechanical damage, and we have been investigating a serious number of bags of this installation. So some dust was brought in, but this was during installation maintenance, so we could not see any real damage, mechanical as well as abrasional damage from any flow pattern or misalignment of the flows. And the most important thing is this one. I mean, we're talking about 38,000 hours, and still this cake and the filter cake is near the surface. The other particles that you see here are most likely accumulates that are transported into this cross section during the sample preparation. So, but you see here a series and a very thin layer of dust, which is just accumulating near the surface of the fabric. So, and this is a real good indication of a very stable filtration pattern, as well as also a reduced mechanical wear. Also the tenacity, and this is more or less one of the criteria to determine the lifetime of a filter material. They are close to the levels of new filter bags. This is due to two reasons mainly. First of all, as mentioned, the operating temperature is quite low, so the chemical aging of the material is not pronounced. Also, the acidic dew points are not a big topic, because then we would normally see some effect on the bags. And the second topic is that the mechanical wear is almost minimized. And this is the main portion of this blended felt construction that does not allow dust to penetrate in, and then later on during the pulsing to, let's say, destroy the filter bags from inside out.
Guenter, we have another question just came in. Can you advise what the filtration velocity was?
It's in the range of 1 meter per minute, something like this. So,
okay.
Yeah, so typical, not overstressing the whole thing. No under. Let's say this is a typical range that the people choose for, let's say, combined scrubbing systems with bag filters. Yeah, the next interesting chart, or let's say not exciting chart, is also this one here, where we really could compare over several investigations. So we started at 8,000 hours, and we had a really good record of this filter unit. So we could not see any big change also in the air permeability. And this is a good indication that there is overall no dust penetration, and also no big clogging of the filter cake, forming a crusty cake. And this again confirms with the quite steady dust incorporation that the performance of the filter bag is by far, let's say, not tending to some limiting lifetime or limiting lifetime expectation for this set of filter bags. So, as you have seen also in this regard, it's all about, let's say, treating the whole system in the right way. So it's the filter bag material is just, let's say, one part of the story, but it needs to be also maintained in a certain way. And this maintenance, of course, is something that starts, let's say, from the installation of the bags with the certain, let's say, and good pre-coating. It continues during the operation that, of course, the desulfurization system is treated in the right way, so there is no big fluctuation in flows and also in dust loads. And of course, in a steady plant operation and also inspection, because one broken bag must not cost too much, but it can ruin a lot of other bags by, let's say, the so-called cross-contamination, when dust is blown, is coming through this broken bag and blown into other bags. So follow-up failure rate is something that can be prevented when you really talk about some preventive maintenance. And of course, if you do some external tests, because you cannot determine the condition of the filter bags by just watching the performance on the PLS systems, you can really have a good idea about the current status of the bags, and also this will help you a lot in your planning of further maintenance of bag exchange before even things happen. So normally the effort as a closing sentence for inspections and preventive maintenance, there is a certain effort in this, but it normally pays back. And don't hesitate to ask if your plant owner don't hesitate to ask some external companies to have a look on filter bags. And yeah, this is normally not our daily business, of course, as we are, let's say, at the very beginning of this production chain of filter materials. But in some cases, when our expertise is needed, we will be glad to assist, either to find the right partner for doing something like this, like an external bag analysis, or we can do it by ourselves. So thank you very much for your time.
Hey, Guenter, we have some more questions here. Great presentation. I actually was just thinking this question that an attendee from the audience also asked. Does the installation of the P84 bags have an effect on overall baghouse DP when compared to traditional bags? Can you answer that?
Normally, we have seen in, let's say, many cases that the DP of the either the cycle time is a little bit longer if you have the same set point of the DP, or you can run the plant at a lower DP than with traditional bags. So we normally, let's say it's yeah, really depending on installation. I mean, we have seen some 10-15% benefit normally all the time, but this is just a rule over the thumb.
Sure, thank you. And along those lines too, can you comment on the acceptable temperature ranges for the P84s?
P84 is, yeah, there are a few, let's say, although there are many brand names of materials in the market, there are just a few real high temperature materials, and P84 is one of them. So we're talking about, if we're talking about P84, then it has an acceptable short-term temperature exposure of 500 degrees Fahrenheit, which is 260 degrees centigrade. So this is one. And then, for example, this is in, let's say, in a similar range than PTFE and glass fabrics offer.
Thank you.
Okay. Hey, Guenter. So, you gave the max temperature there for the P84. PPS I think is down closer to around the 400 range.
Correct. This is 390, something like this. So this is it's a little bit depending. I mean, it's I've been in this field for a very long time, and since the first day there is this temperature discussion ongoing, because it's all a matter of chemical environment, exposure time, and if it comes to temperature peaks, okay, how long do they occur, how often, and so far. So this is one must not forget that the fibers are, let's say, not comparable to, let's say, three-dimensional the same material in a three-dimensional shape, like let's say piping or insulation of a heat exchanger, because fibers have a very high ratio of specific surface to volume, and therefore you need to set certain lower temperature limits for fibers than you would set to the same material configuration when it really has a solid shape.
Okay. All right. Well, I think we'll probably wrap. There's no more audience questions here, and Guenter, I appreciate this presentation and your time. And Mitch, I'll hand it over to you.
Great work, Travis. Great work, IGS, Evonik, our presenters. Fantastic job. Thanks again. Another good episode that we have in the books. We can't do this without speakers and content. This is what everyone shows up for. So special thanks to you guys. Sponsors as well. I mean, thanks for keeping this train rolling. Can't do it without you, as well as to the DSUA board members and advisors that are volunteering their time to make this as cost efficient as possible. So thank you to everyone involved. Stay tuned for the recording of this webinar. If you miss it, want to review some concepts, weren't able to take notes, whatever. This won't be the last time you'll see it, so keep an eye out for the recording being posted. If you are looking for more content similar to this, you can sign up for a membership and get access to all of our presentations dating back to 2008. So really comb through the archives. If you're interested in presenting, you have an interesting story, interesting topic that you want to share with the industry, please submit an abstract through the DSUA website. And yeah, keep an eye out for updates for next month's webinar. Appreciate everyone's time and hope you have a great rest of your week, and we'll see you on the next one. Thank you, guys.